Okay, so this is my midterm too. So for chapter 7, I did problem 3. Um, in 1990, Walter R. Fuel of Belgium, lifted a 281.5 kg object through a distance of 17.1 cm using only his teeth. A. How much work was done on the object by R. Fuel in this lift, assuming the object was lifted at constant speed? So I took the givens, mass, the change in radius, and then converted the change in radius to meters, and then I had theta. And then constant speed, a equals 0, there's no acceleration. So work done is pushing down on Walter on his teeth, so the force will be negative. So I calculated all the work and got 472 joules. And then for B, it was what was the total force exerted on our fuel's teeth during the lift. So I defined force, and then I did, since it's in the opposite direction, I had a positive. The force was negative, but since it was already negative before, it changed to positive. So I did mass times grams that I was given, and that gives me 2,758 newtons. Okay, so for chapter 8, I had a boy in a wheelchair, total mass 47 kg, has speed 1.4 meters per second at the crest of a slope, 2.6 high and 12.4 long. The bottom of the slope, his speed is 6.2 meters per second. Assume air resistance and rolling resistance can be modeled as a constant friction force of 41 newtons. Find the work he did in pushing forward on his wheels during the downhill ride. So I got put in the givens, the meters, the initial velocity, the final velocity, the height, and the length, and then I had a little model right there of like what was happening, so I could understand it better. Then I had the friction force, and also had the height final, and then I had to find work, and I had this equation for change in the energy, and so the work is change in energy, force, and then change in length, and then I got this formula for that, and then the kinetic changes to 1/2 mv final squared minus 1/2 mv initial squared, mgh final minus mgh initial, and then since the height at the end of it will hit 0 when he's at the end of the ramp, that just gets canceled out, and then I just plugged in the numbers, so I got that, and then I calculated it and got 168 joules. Okay, for chapter 9, my problem was number 23. A 10-gram bullet is fired into a stationary block of wood having mass m equals 5 kilograms. The bullet embeds into the block. The speed of the bullet plus wood combination immediately after the collision is 0.6 meters per second. What was the original speed of the bullet? So I had the givens, the mass, which I labeled M1 for the mass of the bullet, 10 grams, which I had to convert to kilograms, so it was 0.01. And the mass 2, which is mass of the wooden block, which is 5 kilograms, that was already converted for us. Velocity, the second velocity initial is 0, because that's like the velocity of the wood. It's not moving before it's like getting hit by the block. The velocity final equals 0.6 meters per second. So that's when the block and the bullet is hitting at the same time. So we tried to find the original speed of the bullet, and it's a perfectly inelastic system. So the change in momentum equals 0. So if that is the case, then the initial momentum equals the final momentum. And the first mass times the first velocity initial plus the mass squared, or the second mass, times the second velocity initial equals the mass 1 plus 2 all multiplied by the final velocity. And then I tried to with that equation, which I got with the momentum. I tried to find the first velocity and the initial velocity, because I was trying to find the original speed of the bullet, and I labeled the second thing as the wood block. So then I have the velocity. I just moved it around, and then I basically plugged it in. I got 30.1 meters per second, or I meant 301 meters per second. I couldn't read that. So after 10, I did problem 48. A horizontal 800 Newton merry-go-round is a solid disc of radius 1.5 meters. It started from rest by a constant horizontal force of 50 N applied tangentially to the edge of the disc. Find the kinetic energy of the disc after 3 seconds. So givens were 800. The work is 800 newtons. Radius is 1.5 meters. The angular velocity initial is 0, and then force is 50 newtons, and time is 3 seconds. So we have to first find the mass. So work equals mass times gravity. So then I solved for mass, got 81.6 kilograms. Then I had to find inertia. So inertia equals 1/2 mass times radius squared, and then I just plugged in and got 91.8 kilograms times meters squared. And then I had to find angular acceleration, and angular acceleration equals force times radius over inertia, because the torque equals force times radius, and then you can divide the inertia over to get the angular acceleration. So then I had angular acceleration, and I plugged in the numbers, got 0.817 rads per second squared, and then I had to find the angular velocity, and then it was under constant acceleration. So the velocity final equals the velocity initial plus the angular acceleration times the time. So then I just plugged in, I didn't have an initial, we were given that we didn't have an initial angular velocity. Then we solved for the angular acceleration, had the time, we get 2.45 radians per second. And then finally, we solved for the kinetic energy, which was what we were solving for in the problem. So then we get k equals 1/2 inertia velocity final squared, and then k equals, then we plug everything in that we've gotten, and then we get 276 joules kinetic energy after 3 seconds, which is the answer. So for chapter 11, I did problem 28, which was the distance between the centers of the wheels of a motorcycle is 155 centimeters. The center of mass of the motorcycle, including the rider, is 88 centimeters above the ground and halfway between the wheels. Assume the mass of each wheel is small compared with the body of the motorcycle. Engine drives the rear wheel only. What horizontal acceleration of the motorcycle will make the front wheel rise off the ground? So I did a little model to show that's the center of mass. That's like the distance, horizontal distance, vertical distance, and that is like the whole thing between 155, and then that's the normal force. That's mass times gravity. Yeah, and then I did the problem. So then the torque equals torque final minus torque, and then equals inertia times angular acceleration. So then I solved for that, plugged in my givens, and then I got, and angular acceleration is equals 0. So I did the force in the y direction, normal force minus the force of gravity equals 0. So then N equals mg, and then I find horizontal force. So there's just the only horizontal force was the static friction. So then Fs equals max, and then I substituted the two equations that we found and plugged in the givens. So I did there, and then I solved for ax. The acceleration in the x direction, which came out to be 8.63 meters per second squared.